so this one we've got a particle moving, its acceleration is 5 minus 2x on x cubed, and it starts at rest, so it starts when v equals 0 at rest, and x equals 1. Alright, so this is at t equals 0, so that's when it starts. All this is happening. What's happening with the acceleration? Well, if we sub in x equals 1 into the acceleration equation there, we have 5 minus 2 on 1, which is 3, so we have a positive acceleration. So our acceleration is, there we go, is 3, so it's positive. So you can see it's kind of pushing off from where x equals 1. It's pushing off from rest, and it's going in that positive direction because the acceleration is positive. All right, so let's look at B, and we need to find a velocity equation in terms of x. So we know we can just use d by dx of half v squared for acceleration. And actually, I might just even put this. So I have 5 on x cubed minus 2 on x squared, or 2x on x cubed, so that's fine. Half v squared, and we can integrate with respect to x the other side. So we've got 5 on x cubed minus 2 on x squared with respect to x. Alright, so that is 5, so that's x to the minus 3, so we've got minus 2 on minus 2, minus 2, x to the minus 2, so it becomes, add 1, minus 1 on minus 1, so that'll be a plus. Alright. If I make v squared the subject, I multiply everything by 2, so I'm going to get a minus 5. That 2 is going to disappear. I've still got the x squared, the x to the minus 2. This will become 4 on x, and now this will be 2 lots of c's, or I'll just call it d. And if I make v equals 0, so we know from here v equals 0 when x equals 1, so we've got 0 is minus 5 plus 4 plus d, so you can see here that d will be equal to 1. So we actually get v squared equals minus v on x squared plus 4 on x plus 1. And if I put everything on x squared over this side, and I might put the x, the positive part first, so we've got that'll be a 4x, because x on x squared is 1 on x, so a 4x, that'll be a minus 5, and that'll be a plus x squared. I could have put that one first as well. Anyway, I'll do that next. All right, so then when I go to square root, you know I'll get a plus minus. Square root of x squared, so that bottom part will just be x. And then I've got the square root of, I'll write it, x squared, 4x, minus 5. Now, why do we take the positive version? So why do we just take that positive version? So if you have a look again at the beginning, we're going in this direction, and it's a positive acceleration happening, and so the velocity will also be positive. So even if I just check something like just after x equals 1, right after x equals 1, I'm going to get a positive velocity. So you can actually try something and put that in. So we need this to be positive here. There we go. It's got to be positive. All right. So what about C? Describe the behavior of the velocity of the particle after the particle passes x equals 5 on 2. All right. So if you even, so these questions are a little bit weird because they're not meant to be HSC questions as such. So you'll see in the book it says, you know, graph it using Desmos or something. But what you can do is have a look at how velocity changes when we change x. So we know when x starts at 1, we've got a velocity of 0. And then if we put 2 in, you can actually just sub it into the equation. You'll get 1.3228, something like that. If I put, so this says 5 on 2, which is 2.5. So let me do 2.5. So when we sub 2.5 in, I get something like this. So then I'm going to sub it. I'm just going to sub a couple more in and see what happens. So when I sub 3 in, I got 1.3333 repeater, I think. 4 was 1.299, 5 was 1.2649. So you can see the velocity went from 0 and it went up so 2.5 kept going up, and then from 2.5 it's making its way back down. So let's have a look to see what happens as x goes to infinity, and you'll see that you can think about it in different ways. But if we go back to our this here, x squared plus 4x minus 5 over x. As x goes to infinity, this part will kind of win out on the top. This one's going to get really bigger much faster than the others. And you see you've got the square root of a square, so really it's just going to be an x. So in the end, you're going to get an x over an x from the bottom, which equals 1. So you can see velocity is going to go towards 1. So when it says describe the behavior of the velocity of the particle after it passes that, all right, so it goes towards 1. It comes back down, so it gets less and less, but kind of has an asymptote because it goes towards 1. It never goes past that 1.